Okay, first worksheet of hypothesis testing. You can pause the video here so you can read the problem. Okay, let me start. We are given right here that at least 90% of all American homes have one smoke detector. And then a city's fire department has been running a public safety campaign about using smoke detectors. Okay, and so the city is now wondering if the campaign has been effective, such that the city's rate is above the national rate. Okay, and for the study, 400 homes were randomly selected. So this is our sample size here, and out of that 400, 376 have smoke detectors. Is this a strong evidence that the local rate is higher than the national rate? Okay, it's asking for evidence. So these are typical problems of hypothesis testing. Okay, so the first step in doing a hypothesis test is to state the hypothesis, and we start with HO. HO is the null, meaning nothing has changed, everything is the same. Okay, so if everything is the same, the proportion P, the proportion of homes that have at least one smoke detector for the city is going to be the same as the national rate, and that's 90%. Okay, and we are going to write the state hypothesis right here. The proportion of homes that have at least one smoke detector in the city is 90%, meaning it's equal to the national rate. Okay, and then if that is not true, the alternative hypothesis is that P, and it's saying right here higher, so the direction is higher. So is it higher than, the alternative is higher than 90%, meaning the proportion of homes that have at least one smoke detector is a detector. Let me get that one. Detector in the city is higher than 90%. Okay, so that's our hypothesis. And so the next step is the model, meaning we are going to write our assumptions and conditions here. So if you remember, there are 4 conditions here, standard conditions. There are 3 conditions, the Bernoulli trials, plus the 4th one, which is the success-failure condition. So we write our conditions here. First one, start with randomness. The 400 homes were randomly selected. Number 2 would be the independence. Okay, so whether a home has a smoke detector or not is independent of each other. No? Then we go number 3. This is the constant probability, and we assume constant probability if the sample size is less than 10% of the whole population. So we are going to say the 400 homes is less than 10% of all homes in the city. Okay, and lastly, we got the success failure condition. Okay, and we are going to compute that. The probability of success should be greater than 10. Okay, so we are going to the probability of the number of success. We can get that by solving for n times p. And n times p, our n is 400. Our p is 0.9. And that would be, let's see that one. We got 400 times 0.9, and that's 360. 360, and that's greater than 10. So check, we have success. And then let's solve for failure right here, NQ. And that would be, again, N is 400 times the Q. If our success is 90%, then our failure is 0.1, 10%. And so that would be 40. And 40 is greater than 10. So we have success and failure condition. Okay, so we are going to say right here, with all conditions met, we can use, or we can assume, normal model and perform. What are we going to do? Okay, we are going to be doing a 1 proportion z test. Remember, we say z test because if you remember normal model, we use these z scores, okay, for the normal model. So we are going to do 1 proportion z test.